Alright guys, so today what we're going to do is we are going to fill in those coordinates on the unit circle. Last time we did angles, now we're going to do the coordinates around it, which is going to turn out to be the sine and cosine of those angles. And so I'm going to show you how to find the sine and cosine of the angles as we go around. Let's start by just filling in those angles in degrees and radians. So let's start with degrees because that's a little bit easier. So here's my unit circle. What angles do we see in the first quadrant? Obviously we start at 0, but then how do you know which angles to do from there?
Divided into 4.
We'll get there. You're thinking radians, right?
No, I'm thinking the 90 degrees.
Oh, okay, yeah, that works. So I split the 360 into 4, so into 90, right?
Yeah.
That's what you're saying? Okay, great. Which means if I do another 90, I get 180. If I do another 90, I get 270. And that takes me another 90 to 360. So Mindy's saying split it into 4s that way, right? Alright, cool. Well, what about these angles right here? What are those going to be and why? 30, 45, and 60 because those are our special right triangles. Or special right angles, right? We have a 30, 60, 90, and we have a 45, 45, 90. And we're actually going to use the 30, 60, 90, or 30, 60, 90 triangles and the 45, 45, 90 triangles to help fill in the coordinates later, but for now we're just writing the degree measures. So, what about this angle? This would be the 30-degree angle in the second quadrant. How do we figure out what this is? Yeah, 180 minus 30, which is 150. Good job. This is 180 minus 45, which is 135. And then this is 180 minus 60, which is 120. Awesome. And I can zoom in a little bit more if you're having trouble seeing that. Okay, now, when I get into the third quadrant, instead of subtracting the angle from 180, we're going to add it on. So 180 plus 30 is 210. 180 plus 45 is 225. And 180 plus 60 is 240. Great, now that's going to take us over to the fourth quadrant. What are we going to do here? Thanks, Melissa. We're going to subtract it from 360. So here's 360 minus 30 is 330. 360 minus 45 is 315. And lastly, 360 minus 60 is 300. And that will be all of our angles in degrees. Were you able to do that on your own? Yeah. If so, great. If not, you're going to need to end up knowing how to do that. You don't have to memorize it, but you do need to know that when you take your 30, 45, 60, you're going to subtract those from 180, add those to 180, subtract from 360, and there you go. We're more familiar with these because we use we talk about degrees. Anytime we talk about rotations, we're more familiar with that. Now, let's fill in the rest in radians, okay? And we might use what I talked about last time, but let's just start with the basics. What is 0 degrees in radians? 0 radians. All right, so everyone can get that one, right? And then if we do 1 complete revolution, we talked about this at the beginning of class. What is 1 revolution in radians? 2 pi. Because remember, it was 6.28, but that's 2 pi. Now that means half a revolution is what? Plain old pi. Now, I'm going to highlight mine real quick. I'm not going to do it super detailed, but what I'm going to do is I'm going to take this pi, and I'm going to split it into fourths. And actually, I'm going to take the 2 pi's and split them into fourths. So I'm going to have 8 pieces here, okay? So this is piece 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to eat those pieces. Sorry if you couldn't see that very well, but here we go. Okay, so 0 pi, we're good. If I eat one piece, that was 1 out of the 4 pieces of this pie, so I call that pi fourths. When I go to 2 pieces, that's 2 pi out of 4, but that reduces to just pi halves. We're always reducing. Now I go to 1, 2, 3 pi fourths. And then I do 1, 2, 3, 4 pi fourths is just pi, so that's just plain old pi. Okay, let's keep on going. 1, 2, 3, 4, 5 pi fourths. So this angle right here is going to be 5 pi fourths. Then when I go to 6 pi fourths, that's going to reduce to 3 pi halves. When we eat 7, that's going to turn into 7 pi fourths. And then 8 pi fourths is just 2 pi, so that takes us around when we split it into fourths. Remember doing this last time? Alright, good. So now, let's switch it up, and instead of doing it in fourths, what did we do next? We did it in 6. Now, this is not going to include the 45-degree ones we did before, okay? But it will include all the others. Oh man, I might need to switch colors. My green is running out. Come on, green. Those look pretty similar. I don't know if you can tell them apart. Let me try. I'm going to cover them in blue and see if that helps. Okay. So now we're going to do my 30, 60, 90, 120, and 150. Okay. So what I've done here, I'm not including the pi fourths ones, the 45-degree ones. I'm now going to change this into 6 pieces. So here's my 1, 2, 3, 4, 5, 6. And then we'll keep going around 7, 8, 9, 10, 11, 12. So we're going to split this 2 pi into 12 pieces, or each pi into 6 pieces, okay? So when I eat this first piece, that is just pi 6, because I ate 1 out of the 6 pieces of the pie, pi 6. When I eat 2 pieces, that's 2 pi 6, but that turns into pi thirds. Okay? Now when I eat 3 pi 6, that's pi halves, I already have that. When I go to the next one, 4 pi 6, that reduces to 2 pi thirds. And then when I go to 5 pi 6, I've eaten 5 pieces, so that's 5 pi 6. And when I do 6 pieces, that's 6 pi 6, which is just pi. So then I've eaten 1 pi when it was split into 6 pieces. When I come here to the bottom, now I go to 7 pieces, so that's 7 pi 6. And then we're going to do 8 pi 6, but that's going to reduce to 4 pi thirds. When I eat 9 pieces, that's 9 pi 6, which reduces to 3 pi halves. I already have it. So then let's go to 10. 10 pi 6 reduces to 5 pi thirds. 11 becomes 11 pi 6. And last but not least, 12 pi 6 is just 2 pi. All right. This is what we did last time, and this is kind of a review. But are you getting the hang of it? Could you do this on your own? If I gave you a blank unit circle, could you fill it in?
Yes.
The answer is you should be able to, if not, get some help. Could you also just times all of these by pi over 180 and reduce?
Yeah.
Sure. Now what we're going to do is we're going to fill in these coordinates on the outside. Some of them are going to be really easy, and the rest we're going to use our special right triangles for, okay? Skylar, will you put your phone away, please? Thank you. Okay, let's go. Good work. Okay, let's do a quick review of our special right triangles. So, in a 45, 45, 90 triangle, how do I get from one side to the other? For example, let's say I'm working with this guy right here. If this leg is 6, what does that mean the other leg is? It's also 6. And what do you times the leg by to get to the hypotenuse? Square root of 2. Nice job. So it'd be 6 squared to 2. So to get from here to here, we times by the square root of 2. By the way, this isn't in your notes, just follow along with me. But what if we're on the hypotenuse already? How do we work backwards to the leg? Thank you. So if it was already 15 square root of 2, take off that square root of 2, it's just 15 and 15, right? So I divided by the square root of 2. Okay, that's a quick review with the 45, 45, 90. Let's do a quick review of the 30, 60, 90. Remember, we have the legs here, they're different lengths. We have a short leg and a long leg and the hypotenuse. And I think it's easiest when you start with the hypotenuse. What do you multiply it by to get to the hypotenuse? Or sorry, did I say hypotenuse? I don't know if I said the wrong thing. Let me start over. We start with the short leg. How do we get it to the hypotenuse?
Times by the square root of 3.
Ooh, that's the other way.
Divide by the square root.
There you go. Jay got it. You times it by 2 to get to the hypotenuse. Now when you're going to the long leg, that's when you times it by the square root of 3. That's going to give us 7 square roots of 3. So to the hypotenuse, you double. To go to the long leg, you times by the square root of 3. But what if you start off with the longest leg? What are we going to do to work backwards to the short leg?
Divide by the square root of 3.
Divide by 2.
Oh, is this that? Oh, I thought we were starting from long way.
Yeah, this is the hypotenuse. And then we'll times that by the square root of 3. Okay? Now, the reason why we're doing this is because what we've been working with is called the unit circle. It's a circle which is centered at the origin. The origin is a point 0, 0. So this point right here, 0, 0. Now, it's called the unit circle because the radius is 1 unit. So radius equals 1 unit. So we call it the unit circle because the radius is 1. Now, that makes it really easy to figure out 4 points here because I just go 1 to the right, 1 up, 1 to the left, 1 down. If I go 1 to the right, this point would be 1, 0. If I go up, this point is 0, 1. If I go to the left, this is a point negative 1, 0. And if I go down, this is a point 0, negative 1. Now, what I want you to do is go on to your unit circle. We filled in all of the angles now in degrees and radians, right? What I want you to do is to fill in these 4 points. We've got the point 1, 0, 0, 1, negative 1, 0, negative 1. Remember, we always do the x first, and then we do the y, so make sure you do that. And you need to remember, why do we call it the unit circle? Because the radius is what? 1 unit, okay? That's going to be important here. Now, that was 4, but we're missing 3 in each quadrant. We're missing the 30, 45, and 60 degree angles. Well, to help us figure those out, we're going to use our special right triangles, okay? So what we're going to do is, let's look at these in your notes now. If I'm working with a 45, 45 degree, 45, 45, 90 triangle, and I know that the hypotenuse is 1, how can I figure out what the leg will be? What did we say to do? That would be if you started with the leg, so let's do the opposite. We're going to divide by the square root of 2. Good job. Now, when I do that, I'm going to get 1 over the square root of 2, which one of the rules in math is we don't like square roots on the bottom. So how do I rationalize this? Multiply it by itself, right? You're going to square it essentially. But if I multiply the square root of 2 on the bottom, I also have to do it on top. This becomes a square root of 2 over the square root of 4. But what is the square root of 4?
1, 2 taken out.
There you go. So this is square root of 2 over 2. So if we are looking at a 45, 45, 90 triangle and the hypotenuse is 1, then both legs will be square root of 2 over 2. Now, this is what I actually want you to fill in on your triangle. So will you get out your pink triangle? That's the 45, 45, 90. It's an isosceles triangle like this. And I want you to label the angles, 45, 45, 90. But then I want you to label the sides, so the hypotenuse is 1, That means this x length is square root of 2 over 2, and your y length is square root of 2 over 2. And I want you to label that on both sides. So right now you've got your pink triangles, 45, 45, 90. Label the sides and the angles like what's on the board. Did you miss another one? This part right there. This is going to be really important for filling in the unit circle, so make sure you have this filled in both sides with the 45, 45, 90. Okay, once we have that, then let's go to our 30, 60, 90 triangle. This time, our hypotenuse is 1. So in those examples we're looking at, and based on other examples that you've done, how do we go backwards from the hypotenuse to the long leg? Or sorry, from the hypotenuse to the short leg.
Divide by 2.
Thank you. So if this was 1, what will that be? Half of 1, which is 1 half, right? Awesome. So we divided by 2 to get from 1 to 1 half. How do we get from the long leg to the, or sorry, from the short leg to the long leg from 1 half? What will this be? Yes, thanks, Jade. So if I do 1 half times the square root of 3, the square root of 3 just goes in the top, so this becomes square root of 3 over 2. And then the hypotenuse is just 1. Okay, I want you to label your 30, 60, 90 triangle now. Label your angles. Remember, your 30-degree one is always the smaller, the 61 is the middle, 90 is the biggest. And you're going to label the hypotenuse as 1, the short leg is 1 half, and the long leg is square root of 3 over 2. And do that on both sides. So your triangles, when you're done, should be labeled like this or like this. And make sure you label both sides. Alright, so now I'm going to show you how easy it's going to be to fill in your unit circle if you have these special right triangles, okay? So I'm going to jump back to my camera here. And I'm going to fill in the ones that you guys already did that I missed, okay? So I said it's a unit circle, which means it has a radius of 1, so this is a point 1, 0. This is a point 0, 1. This is a point negative 1, 0. And this is a point 0, negative 1. Now let's start in the first quadrant right here. I want to figure out where does my 30-degree angle intersect with my unit circle. Well guys, we already said that it's a unit circle because the radius is 1. That means our hypotenuse here is 1. But look, what is our x length and what is our y length? We already figured out using our properties of special right triangles that to get from the 1 we would divide by 2. This gives us a height of 1 half, which is our y value. We then times the 1 half by the square root of 3 to get the length, which is our x value. So that's square root of 3 over 2. So there you go. At 30 degrees, these are the coordinates where a 30-degree angle intersects the unit circle. So square root of 3 over 2 for x, 1 half for y. Done. Now I'm going to go over and put my 45-degree angle here, right here, and ask the same question. If the 45-degree angle is 1, what does that make the x and the y? Well, they were both divided by the square root of 2, which gave us square root of 2 over 2. Because that is your x and your y value. Okay, now we're going to go to our 60-degree angle. I'm going to put 60 right here. and I'm going to ask what is x, what is y. The x was 1/2, and the y was square root of 3 over 2. And congratulations, you have just filled in the first quadrant for your unit circle. Now, does that make sense how I got those values? I just lined up my 30-degree angle with our 30, 60, 90 triangle and said, here's the x value, there's the y. Are you following me on that? Because basically, guys, I'm going to give you a blank one, and you're going to use your triangles to fill it in. You get that process? Do I need to go over it again? I'm not getting like any feedback from you.
I got that process.
As we're going to keep going around the circle, but let me just show you again. So, with my 30-degree angle, what is the x? It's square root of 3 over 2. What is the y? It's 1/2. So I just put the length for x, the height for y. 45, they're both the same. So here's the x, here's the y. 60 degrees, they're both the same. Here's the x, here's the y. Okay, now we're going to jump over to the second quadrant. However, when we do, what's going to change? What's the difference between the first quadrant and the second? Well, in quadrant 1, the x values were both positive. The x values were positive because we're going to the right. And the y values were positive because we were going up. Nothing was negative. But when I go into the second quadrant, what is going to become negative?
X.
There you go. The x values become negative. What about the y values? They stay positive. So, when I'm looking at these angles now, we're going to see similar values of what we saw before, except x is going to be negative. So let's start at 150. 150 uses our 30-degree triangle, right? Now I'm going to ask myself, what is the x and what is the y? And it's going to be square root of 3 over 2 and 1/2, except we're going to the left now, so this is a negative square root of 3 over 2 for the x, and the y is going to be a positive 1/2. All right, let's go to the 45, 45, 90 triangle. This is for my angle of 135 as a reference angle of 45 degrees, so I'm going to put that right there. And I'm going to say, what is the x and what is the y? Well, just like before, it's square root of 2 over 2 for both, except the x is now negative. So it's negative square root of 2 over 2 and a positive square root of 2 over 2. Okay, then let's put in our 60-degree angle. And that's going to be for 120 degrees because those add up to 180. And my length is negative 1/2. My height is square root of 3 over 2. So I'm going to put in negative 1/2 and a positive square root of 3 over 2. All right, now hit the pause button. How do our coordinates from the first quadrant relate to the coordinates in the second quadrant? What similarities are you noticing here? There you go. So when I look at these 30-degree reference angles, I use the 30, oh man, that's not a very good line, sorry. I use the 30-degree triangle at 30 and at 150. Look at their coordinates. They're the exact same except the x was negative here. When I look at the 45-degree triangles, that was at 135 and at 45, they have the same coordinates except the x was negative. And what about at the 60-degree angles? Same coordinates except x is negative. So then what do you think is going to happen when we go into the third quadrant?
They're probably going to be flipped. Or the same.
They could be flipped, they could be the same. Well, why don't we think about how is the third quadrant different from the first and second?
It's upside down.
In the first quadrant, x and y were positive. In the second quadrant, y was positive, but x was negative. What's positive, what's negative in the third quadrant?
They're both negative.
They are both negative. The x is negative and the y is negative. Nothing is positive here. It's a very depressing place to be. It's all negative, all right? Well, let's start with our 30-degree triangle.